All right, class, in this video, we're going to continue system of equations and substitution. So this is part 2. We're just going to work 3 more examples and provide 3 more practice problems. Now, what you'll notice in this first example is I don't have it written as y equals mx plus b. I'm going to have to manipulate one of these equations to substitute. Now, the easiest one to manipulate is the first one, and it's because you have a y with a 1 coefficient. So if I were to mess with this one, and I need to solve it for, say, y, I'm going to end up with some fractions. It's going to be a little more complex. That's workable. I can do it. But as I've said in class, fractions are our friends, but sometimes we love our friends best from a distance. So if I can avoid them, hey, let's avoid them. I can rewrite this equation by adding 3x to both sides as y equals 3x minus 13. And now I have something that y by itself is equal to. So using substitution, I can plug it in for the y right there. So why don't we do this? 4x plus 5, remember we have to open our parentheses, plug in everything that y equals, close parentheses, equals 11. Now we have to distribute. All right, remember your distribution. You take the 5 and you multiply it by everything on the inside. So our new equation is 4x plus 15x minus 65 equals 11. So once I combine my like terms, I'm going to have 19x. I'm going to add 65 to both sides, which is going to give me 76. So now I'll divide both sides by 19, and I get x equals 4. So I have my x value. Let's plug this in. Why don't we use our top equation, y minus 3, plug in the 4 for x, or I'm substituting there, equals negative 13. So this is going to be y is equal to, y minus 12 equals negative 13. I'm going to add 13 to both sides and get y is equal to negative 1. So my solution is going to be 4, negative 1. These two lines right here, these two lines in this system, they will intersect at the point located at 4 in the x and negative 1 in the y. Again, let's go back and make sure we check our work. So that's going to, let's use the bottom one. 4 times 4 plus 5 times negative 1 equals 11, does it? That's going to be 16 minus 5, and yes, that does in fact equal 11, so I feel good about my answer. So the only thing different about this process now is that in this top equation, I had to rewrite it in the form of y equals mx plus b. I had to solve for this variable y so that I have something, one part of an expression here that I can plug in for y. I want you to pause the video and try the practice problem. All right, so again, in this one, same rationale. This time I'm going to solve for x, though. Watch this. This is going to be x equals negative 4y plus 3. You'll say, well, that's not written in the form of y equals mx plus b. That's true, but that's okay, because I just need one variable by itself on one side of the equal sign. In this case, that's x. And so x equals negative 4y plus 3. And this time I'm going to plug it in for x. So that's going to give me 2, open parentheses, negative 4y plus 3, close parentheses, minus 3y is equal to 17. I have one equation with one unknown. So that's going to, and that means it's solvable. Negative 8y plus 6 minus 3y equals 17. So that's going to give me a negative 11y. I'm going to subtract 6 from both sides and get 11. So y is equal to negative 1. See, all I did was solve for y first. I've been solving for x first. Now we got to plug this back in. X plus 4 times negative 1 equals 3. That's going to give x minus 4 equals 3. Or I'm going to add 4 to both sides and get x equals 7. So my solution is going to be 7 and negative 1. This is what I believe to be the solution for these two expressions, this in the system, 7 and negative 1. So now we've got to check it. I'm kind of running out of room here, but hopefully we can make it work. 7 in the x plus 4 times negative 1 equals 3. That's going to be 7 minus 4, which does in fact equal 3. So it does check. All right, let's scroll down and look at this problem. Now here, they've been kind to us. We've made this work. They've said y, we have y on one side equal to x plus 5. So I'm going to plug this in for y. 2 times x plus 5 minus 2x equals 10. So once I distribute, that's 2x plus 10 minus 2x equals 10. Now do you see what's happening? Now let's just play this out so you can see it. 2x minus 2x, well that's 0. Subtract 10 from both sides, and that's 0. Now look, this is a true math statement. 0 does in fact equal 0. What does this mean though? It means there are infinite solutions. Let's give you one example. What if I said, oh gosh, let's try 1 and 2. Let's try 1 and 2. Let's use our top equation. All right, so I'm going to give you just a couple of examples. I've written down 1 and 2. 1 in the x, 2 in the y. And you'll notice that when you plug this in, that doesn't work. I plug in 2 for the y, 1, and that 2 equals 6. Excuse me. No, 2 doesn't equal 6. So, but I said there's infinite many solutions, right? Well, I did, and it's true. But this one does not work because it is not a point on either of these lines. Let's do a different example. What if I tried 1 and 6? Now, this is a point on this line. Because think about it, if I plug in 6 for y, 1 for x, that's a true statement, right? And that does in fact work. What if we just tried this point with the other one? 2 times 6 minus 2 times 1 equals 10. Well, that's going to be 12 minus 2 equals 10, and that does work. That works as well. And so I can come up with other points on this line, and it's going to be the same thing. As long as they're an actual point on the line. You can't just make up random coordinates. But if you were to graph this line, for example, any point on that line is going to work. There is infinite many solutions that's going to cause these to work. Now, we really need to illustrate this a little bit better because in our previous videos, we talked about parallel lines. We talked about lines having the same slope, lines having the same y-intercept. And that's exactly what happens here. That's going to be 2y equals 2x plus 10. Divide everything by 2, and you get y is equal to x plus 5. All right? They're the same line. I probably should have pointed that out first, but I just kind of wanted you to see the math as it works and kind of plays itself out. So when you get 0 equals 0, it's infinite number of solutions. Go ahead and pause the video and try the next problem. All right, so in this case, I'm going to go ahead and substitute again. I'm going to have 1/2 times 2y plus 4 minus y is equal to 2. So that's y plus 2 minus y equals 2, and you can see what's about to happen. 0 equals 0, infinite solutions. And again, one way to see this is what happens if I were to say negative y is equal to negative 1/2 x plus 2. That becomes y equals 1/2 x minus 2. And what happens with the bottom one? That's going to be let's see here, negative 2y is equal to negative x plus 4. Divide everything by negative 2, and you get y is equal to 1/2 x minus 2. And you can see they also have the same, they're the same line. So we're going to have infinite many solutions. All right, I believe we've got one more set here. So let's try these real quick. Look at this last example here. All right, this is going to be an example of no solution, and it's actually really easy to see. Notice how they're both right now written in the form of x minus y, but yet they equal different things. Well, that's no solution. Because think about it. What if I just said, well, okay, if x minus y equals negative 4, then I could really rewrite this as negative 4 equals 2/5, right? I just substitute the negative 4 in for this, but negative 4 does not equal 2/5, and therefore it is no solution. Okay, go ahead and pause the video and try the practice problem. All right, so in this, you're going to see the exact same thing. They've tried to trick you, but we could really just rewrite that as 7x plus y equals -2, right? There's no sign changes. We just flip them. Well, if 7x plus y equals 9, let's just substitute. And we know that 9 does not equal -2. That just simply doesn't work, and this is a no solution problem. All right, guys, this is the substitution method. You're doing a lot of substitution through these practice problems. There's different things to see. I hope these videos help, and let me know if you have any questions.